Good morning. Happy Tuesday. We are going to quickly go over the homework. I was so impressed. Most of you did fantastic with this homework. If you can tell, I'm not going to go through 10 through 14 because, the majority of you got this right as I'm sitting here looking through your responses. The most mistakes were with 15 through 17, and not really that many on 17. So 15 and 16, and that's because they're the most complicated ones. So I'm going to run through those really quickly, and then we'll start our new material. Okay. People next door are cutting down trees, so just FYI if you hear that. Okay, so and now I hear a toddler coming inside, so you might also hear that, but that's okay. All right, so number 15, I don't think y'all had trouble breaking down the denominator, the 75. I think it was when you had to go to the next step, or the final step, honestly. Okay, so this is the problem child, so that's what we're going to multiply to the numerator and to the denominator. And then we'll have 7 root 3, and here's where I think some of you made your mistake. So this 5 has to come over, and then when we do this root 3 times root 3, we get plain 3 or root 9. Okay, but remember our shortcut is just plain 3. Now you have to remember to multiply those. Okay, so your final answer should be 7 root 3 over 15. Some of you had 7 root 3 over, well, actually most of you had it. One or two had the numerator incorrect, and then 1 or 2 people had the denominator incorrect. So again, for the most part, you guys did it well. Okay, now 16 is one of those ones where you can take and you can divide this by 4. However, that is not the largest perfect square, so that's where some of you went wrong. 4 is not, in my opinion, the best perfect square. 16 is the best perfect square. Okay, because it's larger, and so therefore it's simplified more quickly. So you should have 4 over, and then the square root of 16 is 4, like that. All right, so now again, the problem child is just this root 3. So that's what I'm going to times the numerator and denominator by. So now I'm going to have 4 root 3 over. All right, remember, the 4 comes down first. Then when I multiply these two, it's going to be 3. So that's 4 root 3 over 12. Some of you, or a lot of you, actually left. I see several people put 4 root 3 over 12. But this is not the final answer because this fraction right here can be simplified. And so 4 can divide into both of those numbers. So our final answer should be root 3 over 3. Okay? All right. And then the last one, most of you got it right, but I just wanted to reiterate that we get in the habit of trying to break these things down, but these should be kind of a red flag to you because they are both perfect squares. So 100, right off the top of your head, you should know that the principal square root or the positive square root is 10, and then of 64, it's 8. All right, now some of you just put 1.25 on, well, 2 people did. That's fine. I'm gonna typically leave everything in fraction form. So we can divide both of these things by 2, and so our final answer should be 5/4. Okay. Some of you had root radical 80 or 10 root blah blah blah. You don't have to actually, do any quote unquote hard math because they're both perfect squares. I just wanted to throw that one in there to show you, kind of like number 12 at the top. All right, so see if you need to make any corrections there before we move on. Okay, so now we're getting into the fun stuff. We are going to talk about right triangles. I'll post this Word document, so if anybody wants to print it out, you can do that and follow along the notes if you want. Otherwise, if you'll just kind of take notes as we go, that'd be great. Okay, so let's talk about, first of all, you're going to see this symbol a lot, and it has a name. It's a Greek symbol for theta, okay? Sometimes based on the way I say it, some students are always like, what are you saying? So theta is the way that you say that. and it stands for an angle. Okay, so it's kind of like using x or y, a variable, but instead of using x, we're going to use theta. Okay? All right, so we're always going to label sides according to wherever theta is located. I can put theta here, or I could put theta there. All right, so I can move theta around, but I'm going to leave it where it is in this picture. So we are going to label sides using some specific words. Now you should already know what this side is called. Okay, we have talked about that before. So the one that is directly across from the right angle is always called the hypotenuse. Okay, you'll see me abbreviated a lot with like HYP. Okay, then we're going to use arrow. I use arrows a lot. Y'all know you've seen me do that before. The angle the side, that's across from the theta is always going to be the opposite side. Okay, it is opposite the angle that we're looking at. And then the last one is the one that's right beside the angle, and we've used this word before. We just used it with angles, but now this side is adjacent to theta. Okay, so these are the key words we're going to be looking at. You're going to see me use abbreviations, O, H, and A a lot. Okay, so opposite, hypotenuse, and adjacent. I always label them hypotenuse first, then the opposite, and then the adjacent last. Okay? All right, so now let's practice doing that same thing, like labeling the sides, but with problems where I've kind of moved the triangle around. Okay, like flipped it around or rotated it, etc. All right, so let's label it says which is the hypotenuse. So first of all, that's always directly across. And how do we name sides? We name them with two letters. Okay, so that is side AC, or you could have said CA. All right, it says which leg is opposite theta. So here's my theta, so I'm going to go opposite or across, and that would be BC or CB. And then the adjacent side would be the one that's beside it. Now, do y'all see you could also say this is beside it, but we've already labeled that the hypotenuse. And if you wanted to do that, we could. And then now this one's adjacent. Okay, so it can't be more than one thing. Once you've labeled it the hypotenuse, it's done. All right, so the adjacent side is AB or BA. Okay, either one is totally fine. All right, why don't y'all take a second and do this one, pause the video, and then I'll go through it. Okay, I hope y'all did okay with that. So hypotenuse is always across from the right angle, opposite is across from the theta, and then adjacent is the remaining side. All right, those names will help us with our trigonometric ratios. Now that sounds like a lot. Ratios, you remember, is just like a fancy word for fraction. We've talked about that before. So we're going to be leaving things in fraction form. All right, so our trigonometric ratios are sine, cosine, and tangent. Now, you've probably seen those on your calculator before and been like, I have no idea what that is. So sine, cosine, and tangent. That's how you say that. Now, a lot of students will want to say sin, but the way that you say this is that way, right? You're not going to spell it that way, but that's how you say it. And then cosine is cosine. That's how you'd say that. And then tangent, you've heard that word before, so that one shouldn't be new. Now the abbreviations are going to be sine, but it's without the E. Now it looks like sin. Please do not say sin, okay? And then cosine, and then we're going to have tan. Okay, and now we're going to learn the fractions or ratios that equal these trigonometric ratios. So the sine of any right triangle is the opposite side or the opposite leg divided by the hypotenuse. Okay. The cosine is going to be where you take the adjacent leg and you divide it by the hypotenuse. And then the tangent is the opposite divided by the adjacent. Or you could also think of it as sine over cosine. Okay? I don't think you really need to worry about that. I teach it in pre-cal where you really do have to remember the sine over cosine, but this one is the most important. Okay? So there is a mnemonic device to help you remember this, and you may have heard it if you have siblings that are older. It is typically one of the things that students remember the most from math. Okay? You may have seen a meme or something before that's like, I don't know how to do my taxes, but I know how to do SOHCAHTOA. Like, you know, basically saying that SOHCAHTOA is not super important, but we all remember it. I've seen several memes like that on Instagram where they make fun of kind of some of the stuff we teach and don't teach, and SOHCAHTOA is typically one of them. So here's what the purpose of SOHCAHTOA is. So the way I'm saying it is so, like S-O, so, and then CAH, C-A-H, CAH, and then TOA, sounds like toe sorta, TOA, and then that helps me remember sine, cosine, and tangent. So the S in so stands for sine, the C in CAH stands for cosine, and the T in TOA stands for tangent. And then the O and the H stand for opposite and hypotenuse, which is the formula, if you see that. Okay, so it's a mnemonic device to help you remember the order in which your trig functions go and what is over what. Okay, so then in CAH, it's cosine equals adjacent over hypotenuse. And then TOA is opposite over adjacent. Okay, all right, so we're going to do 3 problems using SOHCAHTOA. Now, y'all know how you write down stuff at the top of your paper when it's important? I know you do. So this is what I would like for you to do every single time we're working these problems. Oh, I hear Samson. We must have a delivery. That's my dog. Okay, so SOHCAHTOA. All right, so I would like to have you to write that down on every single page for the next several weeks, okay? Or I don't know about weeks, but however long we do this. So it's going to be very important. All right, so we're first going to look at this problem. Now, do you see I've given you the triangle and I've given you all 3 sides, okay? So we know all 3 side lengths, 3, 4, 5 units, whether that's centimeters, inches, we don't know. And I've also given you theta. So first we want to start with theta and we want to label our sides O, A, and H, okay? So let's first label our hypotenuse. That's the easiest. Then we're going to label the opposite, and then we're going to label the adjacent. Okay? And now we're going to fill in our answers. All right, so sine is O over H. And our O side is 3, and our H side is 5. Do y'all see that? So the O side is 3 and the H side is 5. And so we're done. 3/5. That's your answer. That's all you got to do. All right. Now cosine is the adjacent over the hypotenuse. So the adjacent over the hypotenuse. So our adjacent side is 4 and the hypotenuse is 5. 4/5. We're done. And then the tangent is TOA, O over A. So our O side is 3 and our A side is 4. And that's it. Okay? Now let's make it a little harder because that was pretty easy. So with the next 2, do y'all see, I've actually copied them for another page, but do y'all see I have taken away a side, right? So you need the hypotenuse to be able to, I assume you all understand it is the hypotenuse, right? We need the hypotenuse to be able to do sine and cosine. So we got to figure out what the hypotenuse is. So how do we figure out what this hypotenuse is? I've blown them up on this other page. Okay? All right, well, let's first label what we know. So we know this is the O, and we know that this is the A, and we're missing the H. So how do we figure this side out? Well, there is a formula that you learned last year, actually before that even, but that you also used last year, called Pythagorean theorem. Pythagorean theorem states that a squared plus b squared equals c squared. You guys, this only works for right triangles, but every single problem we're going to be doing over the next couple weeks will be right triangles, okay? All right, so let's fill it in. If you remember, a and b can be interchangeable with the legs, okay? It doesn't matter which one is which, okay? So we could put 6 or 7 first. All right, so try to keep it as organized as possible. So 6 squared means 6 times itself, which is 36. 7 means 7 times 7, or 7 times itself, which is 49. And notice I'm just bringing this c squared down. No, and now I'm going to add them together. So that's going to be 85 equals c squared. And now we want to get rid of this squared right here, okay? We don't want the squared there, so we square root. So c equals the square root of 85. And now, what do you think your job is? Your job is to see if any of those perfect squares go into it, so if we can see if it simplifies. It actually does not. I'll go ahead and tell you that. So we're just going to leave it root 85, and we're going to put it here. Okay? And now we've done the hard work. We have found the hypotenuse, and now we can fill in our labels. So sine is the opposite side. So what is the opposite side according to this theta? It is 6. And what is our hypotenuse? It's root 85. Okay? Now, is that simplified? I hope that you're in your head saying no. So do y'all see, this is why I did the review from yesterday. So we cannot leave that in the denominator, the radical, so we got to fix it. So times by root 85 on the numerator and denominator. So now our final answer will be, on the denominator, don't think about multiplying 85 and 85, just remember the shortcut that says that. That is your final answer. See if anything can simplify with the 6 and the 85, and it can't, so you're done. Ooh, okay. Let's do it again. All right, so cosine is our adjacent side. So what is our adjacent side? It is 7. And our hypotenuse is root 85. So it basically is the same thing as the previous problem, just with the 7 this time. So we're going to times by root 85, and we'll have 7 root 85 over 85. Okay? Awesome. And then TOA, tangent, is our TOA. It's O, so our O side is 6 and our A side is 7. Look at there. Yay. No radicals we don't have to worry about. That does not simplify 6 over 7, so we're just going to leave it right like that. Okay? All right, and then for our last one, let's do it again. Let's do one more like it. So I have given you 2 legs. I have given you the opposite, and then I've also given you the adjacent, and we are missing the hypotenuse. So we're going to find it using Pythagorean theorem. And we have the legs. Again, remember, I could have switched that around and put 12 squared plus 8 squared. Addition is commutative, so the way that we write it doesn't matter. You can use your calculator here totally, but I think you also could do this in your head, no problem. So 12 squared is 144, and now we're just going to add those together. So that'll give me 8, 208. All right, so now we might want our calculator, because we're going to have to take the square root of 208 to see if that can simplify. First of all, you might want to type it in, the square root of 208, and see if it's a perfect square, because that's a little higher than the ones that we just know off the top of our heads. You'll see it's not a perfect square. So I want to think through those perfect square numbers from yesterday and see if any of those will go into it. So I'm going to write them out. All right, so that'll keep going. We could try higher numbers, but I'm going to try, I think, we're probably okay. We're pretty safe with this. So I'm going to try like 64, 49, 36. If you can hear me typing, I'm just trying different numbers. Now, I do know that something goes into it. So if you just tried 4, for instance, say you tried this one, it does work. It gives you 52. But let's try to find the biggest perfect square. So I think there's probably a bigger one than that. All right, so I found this one to work. So if 4 works, 16 is probably going to work, FYI, since they're, 16 is a multiple of 4. And it does. So 16 times 13. And y'all, 13 is not a perfect square, so we're done. So C simplified is 4 root 13. If that makes sense, okay? Because it was the square root of 208, but the square root of 208 simplifies to 4 root 13. All right, now we can answer our questions. So our question says we want to find the trig ratios. So our sine is our O, which is our 12, and our H is now 4 root 13. Okay, so we have a problem. Actually, we have 2 problems. So we have this needs to simplify, and this needs to come out of the denominator. I'm going to worry about simplifying at the very end, the fraction, but I'm going to go ahead and get rid of the root 13. Remember, the 4 is not the problem, it's the root 13, okay? Does everybody kind of remember those steps? So bring the 4 over, and then root 13 times root 13 is plain 13. And so now we're going to have 12 root 13 over 52. And now I'm just going to simplify this fraction. Okay? So I think 4 is the largest number that'll go into it. We'll see if that simplifies it all the way. So 4 goes into 12 3 times, and then 4 goes into 52 13 times. Let me just make sure of that so I don't make any careless mistakes. And now I can check this fraction again. Does that seem simplified? And the answer is yes, so we're done. So what is an easy concept can sometimes turn into a complicated problem because of that radical, okay? Which again is exactly why we did the review yesterday. All right, so let's do the cosine. So the cosine is the adjacent side is 8, and the hypotenuse is 4 root 13. So I'm going to take care of the problem child just like I did a moment ago, and I'm going to have 8 root 13 over 4 times 13. So that'll give me, I'm sorry, I'm running out of room. So that'll give me 8 root 13 over 52. And now I just need to simplify 8 and 52. Again, 4 goes into both of these. So 4 goes in 2 times. And then you just leave the radical, and 4 goes into 52 13. Okay? There are more correct ways to do this, but I think that's the simplest. All right? And then tangent is much easier, thank goodness. So it doesn't involve the hypotenuse, which has a radical. So the O side is 12, the A side is 8, and then some students are going to be done, but you really need to be careful. That can be simplified. So 4 goes into both of those, and that is your final answer. All right, so SOHCAHTOA is just an abbreviation that will help you with trig problems, okay? And that's where we're going to stop on the notes. We'll pick up there tomorrow with like a little bit harder problems. So you definitely, the biggest thing you need to take away from today's lesson is you need to memorize this formula or that mnemonic device, because that'll help you with your formulas, okay? We did one problem, this one here, where I gave you all the sides, and it was pretty easy. The other 2 problems here were not as easy because I didn't give you the hypotenuse, and also the hypotenuse turned out to be a radical, which kind of made things a little tricky. Okay? So you are going to try to do these 9 problems for your homework. Now let me just go ahead and tell you, you're not going to do the bottom half, we'll do that tomorrow. But with these 9 problems, the first 3 says the sine of r, the cosine of r, and the tangent of r. That just means for those 3 problems, you want to put your theta here. and then label your sides. Okay, obviously you're going to have to find the hypotenuse. Okay, now when you're done with those three problems, 4, 5, and 6 are talking about S, sine, cosine, and tangent at S. So that means you're going to erase your theta here, and you're going to put your theta now at S. Now, what happens with that is the hypotenuse is always going to stay the hypotenuse, but these two sides would switch. Okay, so whichever one was the adjacent would become the opposite, and which one's the opposite would become the adjacent. So just FYI, I want you to kind of make some observations, and then you're going to write those observations down here. Okay, so again, just make sure you understand that you're going to move theta around for 1, 2, 3 versus 4, 5, 6. All right, try your best with those, and we'll discuss tomorrow. Okay, awesome. Y'all have a great day.